the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. Now, this video you're about to see is one of my older videos. The quality is not the same as my new video series. My intent is to make a newer version of this video at some point in the future. However, I want to make sure that students currently using my Mathematics in Review video series have access to as much help as possible when it comes to prerequisite topics. With that being said, let's get started.
To define a formula, it's essentially an equation with, well, I suppose it would be two or more variables. It's a very general, broad statement, by the way, but there's tons of formulas that we know in mathematics. D equals RT is one of them. C squared is equal to A squared plus B squared. Now, this formula is not always true. It's only true for right triangles, where C is the hypotenuse. There's a ton. There's a ton of formulas in mathematics, and I know that students feel overwhelmed. Oh, I have to memorize so many formulas. In general, you don't have to memorize too many. Principal, rate, time. There's a lot of them. Anyhow, so these are all examples, and notice there's just a bunch of variables in them. In this lecture, we're going to concentrate on solving formulas for specific variables. Like in this example, we're gonna solve this formula, which is t equals 4j times the quantity j plus 3k. We want to solve that for k. The rules here are kind of like the same rules that you would follow if you were going to solve an equation. You want to clean up sides, so let's go ahead and start there. I mean, you wouldn't. You want to make sure you do the easiest route, so it takes some experience doing this. But the fact is, I cannot easily solve for k because it's mixed up in this business. So I'm first going to clean up each side. So I have, this implies that t is equal to 4j squared, right? J times j is j squared, plus 12jk, because that's just me distributing across the parentheses. And the second one is kind of the weird one in this case, which is isolate the variables, or in other words, if you have several different versions of k, get them all on the same side. Well, we really only have one version of k. It's this one right here, and it's already by itself on a side. So now we can start untying. If we only have one version of k, we can immediately start to untie. So let's ask ourselves that question: what happened to k? Notice I'm not asking what happened to x, because that's not what we're solving for. So if I look at this equation, what happened to k, let's see, somebody came along and multiplied it by 12j, right? They just attached a 12j right on there. And if you take a look at this equation, there's another way you could have written it. You could have written it as 12jk plus 4j squared. And some people like to rewrite it like that. And when they do, they see, oh, okay, well, after they multiplied that by 12j, they then added 4j squared to it. So now I'm going to untie that. That's how they hid the value of k from me. So I'm going to untie that. So to untie the second step there, the last step they did, I'll subtract 4j squared. And to untie the first thing they did, I'll divide by 12j. So let's go ahead and do that. That's my roadmap. So here we go. Let's see, I'll subtract 4j squared from both sides. Everything has to be done from both sides. And the left-hand side, t and j are two totally different variables, so they can't really subtract easily. So you're just left with t minus 4j squared. You can't combine those two terms. On the right-hand side, the 4j squareds cancel, and you just have this 12jk. So after we're done subtracting 4j squared, I tell myself, okay, now I need to divide everything by 12j. So I will divide everything, this object right here by 12j, and this side by 12j as well. And when you do that, you get the following: t minus 4j squared all over 12j is equal to, on the right hand side, the 12's cancel and the j's cancel, and you get k. And look, that's exactly what I wanted to solve for. A word to the wise here: when you're asked to solve for a variable, like in this case it was k, make sure that that variable is by itself on one side of your equation when you're done. You shouldn't have k's all over the place. You should have a k on one side and that's it. If you have a k on both sides, you've done something wrong. Another thing that that some people might do, they might ask, well, when I did this, I got k is equal to t over 12j minus, let's see, j over 3. That is equivalent, okay, to this answer. It turns out that when you have a fraction like a plus b over c, that's the same thing as saying a over c plus b over c, right? These have the same denominator, so their numerators just add. Well, that means that if I have a fraction like t minus some picture over 12j, I could split this apart to t over 12j minus 4j squared over 12j. And this one, the first fraction is completely simplified, but the second fraction, the 4 goes into 12 3 times, and the j's will cancel to give me only a single j up top. That's how you get that business. So they are equivalent. Neither is more acceptable than the other. It's just two different representations for the same thing. Let's go ahead and solve a equals pi rh plus pi r squared for h. Well, the first step we want to do is clean up the sides, but if you take a look at the problem, there are no like terms. Like there's no parentheses on the right hand side, nor are there any on the left. And on the right hand side, you can't just add these two objects together because they're not the same exact pictures. So there's really nothing I could do. The second thing is to get all h variables on one side, but they already are, right? All my variables, all my terms with h's are already on the right hand side. So I guess I just need to untie this. And I can say that because there's only one version of h. Again, back to my method where I keep saying, no, there's only one version of this, so let's go ahead and untie that. So let's ask ourselves, what happened to h? Now, obviously, you don't have to write what happened to h. It's just, I do, that's all. So the first thing that somebody did when they were trying to hide the value of h from me is they multiplied it by pi r, right? That's that picture they placed right in front of h. And then after that, they added to that with pi r squared. I already know that's an area. So let's go ahead and untie what they did to tie up h. So I'll start with the last thing. I'll start by untying the last thing they did. They added pi r squared. I'm going to subtract pi r squared. And the very first thing they did is they multiplied by pi r. I'm going to divide. Okay, so to start untying this knot, we'll subtract pi r squared from both sides. Go ahead and do that. So subtract pi r squared from both sides. Following my method, you really avoid a lot of extra work, honestly, and a lot of extra thinking. So that's the first thing we do to untie the knot that they tied up. The last thing we do here is to undo that multiplication by pi r by dividing both sides by pi r. So divide the right hand side by pi and by r, and again the left hand side by pi and by r. And you will see, by the way, I forgot my implication signs. And you'll see that the left hand side is a minus pi r squared over pi r. And the right hand side, the pi's cancel. Pi over pi is just 1, and r over r is just 1. So that's 1 times h, or in other words, h. Now, again, this is perfectly acceptable as an answer. However, some might want to separate this out and say, oh, that's like a over pi r minus pi r squared over pi r. The only reason why somebody would want to do this is because they might see that, oh, those pi's, if I could separate out this fraction, those pi's would quote unquote cancel, and so would the r's a little bit. And actually they do, right? Pi over pi is just 1, and r goes into r squared once. So if you did it that way, you would get a over pi r minus r, and that's equal to h. Both very equivalent answers, extremely acceptable in, well, in my courses. I don't know your instructor, but I would have to say this is very acceptable.
Thank you for watching this review video. As I mentioned previously, it's an older video that will eventually be updated. However, it should get the job done for you. As always, this content should be prerequisite to the course in which you're currently enrolled. If you found this material unfamiliar or if it was confusing to you, then I recommend you review any prerequisite material mentioned in the video. If you find you're continually having to research the prereq material here, you might want to consider speaking to your instructor about other course options. On that note, I sincerely hope these videos help you achieve success in your transfer level math and science courses. Cue the music.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.